Mr. Muggy is the manager of the washer and dryer department of an appliance store. He wants to estimate the probability that a customer who comes to his department will buy a washer or dryer, one or the other. He's collected the following data during 1 week. Okay, so this is categorical data, right? I'm definitely feeling the categorical data, and because of that, I'm going to go ahead and write a two-way table. Um, And I believe I'm going to do washer, yes, washer, no. So one broad category there is you're buying a washer or you're not buying a washer. The other category we're going to look at is dryer. And for that, we'll also have dryer, yes, and dryer, no. Now, they're telling us that the 177 customers came to his department. So the total people that came by the department was 177. So I'm going to put that outside in the margin there, down at that corner. It says 88 purchased washers. So washer, yes. 88 said yes to I need a new washer. 64 purchased dryers. So dryers, 64 said yes to the dryers. Um, and also it says that 69 people did not make a purchase. So no washer, no dryer. So based on that information, I believe I can complete this two-way table that we've set up here. Remember, for the two-way table, I'll write this, I'll highlight it, and I can erase this. But these values have to add up to 64. So there's two numbers here. This number and this number must add up to 64. So right off the bat, I can't fill that in because I don't know enough information about that. I do know that these two numbers have to add up to something, right? Whatever this number is plus 69 has to be what this question mark is. So can't quite do that either. Um, Now, going along the bottom, I know 88 plus something has to be 177, and 64 plus something has to be 177 also. And that's where I'm going to start by filling in these marginal stats. So let me bring up the calculator here. I'm embarrassed to say, but I don't. Let's see, 177. I'm not ashamed of using this device. So this is 113, and I should not write with a highlighter. So 113 people go here. So 64 plus 113 should be 177 customers. I don't know why I feel like I should verify that. Plus 64 equals, yeah. And also if I take 177 customers and subtract the 88, that gives me this number. This number should be 89 customers. So I, this is just how I'm just kind of chipping away at this. Um, so I know of the 177 customers that came in, 89 did not buy a washer, 88 did buy a washer. Of the 177 customers that came in, 63 bought a dryer and 113 did not buy a dryer. Now, I can fill in the yes, no's. I'm going to fill in the no's for the washer. So again, these two numbers have to add up, right? So if I take the 89 and subtract the 69 from it, 89. Are you kidding? Are you really doing that in a calculator, Roberts? I get 20. Um, and if I go this way, right, these two have to add up to 64. 64 minus 20 is 44. So those go together. That's cool. Look at now I know that there are 44 people who bought both a washer and a dryer. And then finally, uh, these two numbers have to add up to 88. And 44 plus another 44 would be 88. So of the 88 people that bought a washer, half bought a dryer and half did not. I can answer all kinds of questions now. So that's our two-way table. It's a great way of organizing this categorical data. And now they're going to ask us some questions here. Mr. McGee promises to sell people a bonus if they can increase the probability that the customers who buy washers also buy dryers. Okay, what is the probability that if a customer bought a washer, he or she also bought a dryer? Ooh. Okay, so if they bought a washer, so that puts us in they bought a washer, that's the yes category to washer. So what's the probability that if they bought a washer, that they also bought a dryer? So I can see the total people that bought a washer was 88 people. And of those 88 people, 44% bought a dryer. So I think it's gonna be 44 bought the dryer out of the 88 who bought washers. So again, of all the people who came in and bought a washer, 44 of them bought a dryer, 44 did not. So that means that the probability of them buying, um, what is it again? It says what is the probability that if a customer bought a washer, he or she also bought a dryer? That's a half. That's 50%. I can write it as 0.5. I could write it as 50%, or I could write it as a half. So if they increase that, and there's a couple ways they could increase that. They could actually just well, how could they do that? No, they gotta convince more people to buy the dryers, or they could decrease the total number of people who bought washers. Never mind. Anyways, if it's higher than 50%, they're getting a bonus. So, hey, if you want a washer, you definitely need a dryer. Look, it's a match set. You can't buy one without the other.